Jenkins. Hello, can you hear me? Hello, can you hear me?
Yes.
How are you all
Here.
doing?
Good. How you doing?
Some of you, I got some emails from some of you about the textbook link. I'm working with Barnes and Noble to fix the problem, so nothing to worry about for now. So my name is Joseph Orji, and I'm gonna keep you company this semester. Let me start by showing you the class. You all can see the screen now, right?
Yes.
Okay, good. So I posted some announcement for you just to get you started about the course and about how to access the textbook. Now, to get access to the textbook and also to get access to their homework and tests or exams, you have to go through the My Lab and Mastering. That's where the tests and homework for this class will be located. But before you can be able to access them, you need to click on the course material. You can see the course material tab. When you click on it, it will bring you open a page where you can get the access code. So the access code for now, it is showing me an error message. That's why I've already contacted the Barnes and Noble to fix the problem. But once you click on this course material, it will open the access code. Once you get, then you get access code, then you click on My Lab and Mastering here on this side. Then I don't know how it shows on from your end, but that's how you show on my end. Once you click on that, you can now get the access code. Put the access code so that you can now have us see your homework and your tests or exams. So like some of you, even me, you can see that that link that will show you the access code is not working for now. So hopefully by weekend they should fix it. So there's no homework there now. The only thing you will have to do will be only the classwork. Now, having said that, I will now show you the course syllabus. To access the course syllabus, you can see can you see my cursor moving? Can you see it? Hello guys, can you see my cursor moving?
Yes.
Good. Now, if you take it to see where you have a syllabus link, if you click on it, it will open and you can see where you have the syllabus right here. I'm going to open it. So you can see all of it. That's the syllabus right here. So it shows the class that we have today, which is a remote class. And we are I provided the link for logging in. That's why you were able to log in today. Let me take you to where most students have interest in, which is your grades. This is how you will be graded in this class. I open the syllabus. Okay, this is the course syllabus right here. Let me make sure you're seeing all this. Yeah, this is the course syllabus. And I will take you to where you see your grades. This is how you'll be graded. You have the classwork. This classwork, you do it each time we have a class, every week. So like the one I will give you today will be due tonight, but you can still submit it tomorrow. I will accept it. So what is the classwork? It will be a question I will give you to solve and then upload after you finish. Remember, in statistics class, you have to show your work, and I will explain to you how you do that if it is a math problem or a problem that involves the use of Excel. Now, classwork carries 20% of your grade. Next is attendance and participation. Attendance and participation have 5% of your grade. So when you come to class regularly, you automatically have that grade. You attend and participate. Then test and exam is 25%. This test should be done in my maths, my lab and mastering. I just showed you how you can get to that place, which is here. My lab and mastering. Give me a minute. Somebody was asking me a question. Give me a meeting remotely. Yeah, somebody asked me a question. Didn't see.
Dr. Joseph, is me.
Oh, is you?
I was
Okay. Okay.
I was on here at 6, so that's why I was just asking, are we having class?
Okay. Okay.
A lot of the students were confused, so.
Yes, that's why I sent those messages,
Yeah, I received the message, but they're stating there is no class, and I'm telling them it's class on Zoom, so I don't know.
Well,
yeah, on my end, when I first signed up for the class, it said that we were not meeting at all. You were just gonna like give us work to do. We submitted, not that we meet virtually online.
Yeah, that's what we are doing now, virtually. I mean, virtually means that everything is remotely. Yeah.
Yeah, but when I first signed up, it didn't say virtual at all. It just said online based, and that it was like basically you give us work and we do it, not that we meet.
I don't know. Anyway, even this method is at least now you can see me. You can ask questions. Than when you only do assignment and submit. You're not. You may not. If you're confused about a concept, you might not be able to find the response if it's just submit assignment. Anyway, I'm glad that, maybe this is the first day of class. So probably by next class, there will be people, the other student will understand how the class will be, how the class will be holding. Now, we are still on the syllabus. So the homework is also done in my math lab. Remember, that's what I wanted to show you before I got the message from the student. So it's right here. Say, click on here, and then, but for you to be able to do that, you have to register first by getting the access code from the course material. So we'll see by weekend, hopefully, Barnes & Noble will fix that problem. Now, next thing that is in the next assignment that we use to determine our grade is project. The project, part of the project is include Excel assignments. Just an assignment to be doing Excel. And as a matter of fact, this is a statistics class, and even though we use small sample to provide example in a classroom, but in real life, you'll be working with a large amount of data. How do you do that? How do you analyze it? So that's why it's important to know at least one statistical software, which in this case we'll be using Excel. So the Excel assignment, there are going to be 5 Excel assignments, then plus the final project. And that will be constitute 15% per grade. Then the final exam will constitute 20% of your grade. Okay. Any question before I continue? Any question? Okay, there's no question. Good, excellent. Let me scroll down a little bit. Now, the tests, they're going to be 3 tests and the final exam. Homework, you're going to have homework starting from next week. They're going to be homework every week. It will be completed in my lab and mastering. Quizzes, there will be, I don't give quizzes, so no need to worry about that. Project, yes. Excel assignment, and then the final project. Final project will be like a type document. You generate your own data set, and you're gonna use it to answer the questions on the project document, and then provide the cover page, and then submit. Classwork and then attendance. Now, since there's no question, I want to show you other things, other announcements that I made, and then we can go from there.
I have a question about the classwork. So, like it being due on Wednesdays instead of Sundays. Like how?
No, it is actually due on the day we have the class, but I can accept it the next day. It's different from homework. Homework is the one that will be due on Sundays.
Oh, okay.
Classwork is due the same day we have a class. But however, I can still accept it the next day. Yeah.
Okay.
Like tonight, I'm going to show you an example and then give you one that you do by yourself and submit. Okay. Now, the other announcement I made, we have this one we call, okay, the Zoom link that you use. Okay, this one is the Remind app. I'm using Remind app for this class. If you haven't done, some of you have already did it already. If you haven't done so, this is the fastest way to reach me and to get the quick fastest response from me. So to be able to do that, you see this text message, send it to this number, and then follow the steps there to be put in my class so that I can receive the message. So let's say that I'm going to be late. I can send a message and it will come to you as a text message. Or if I'm about to cancel a class, I can send a message so that you know beforehand and plan ahead of time. Or if there's an assignment that I want you to submit early, I can also use it to send a message. If this number doesn't work for you, you can send it to this number here. And to put you in my list. The other announcement I made was about week. I'll be posting this announcement every week. I recommend that you read my announcements. They are very important. They carry important messages. These are the things we'll be covering this week. You're gonna I'll read chapter 1 of the book, and then we have to have access to reading materials. You go to the models. See the models right here. Right here. I can click on it. I will come to that in a few minutes. Then once this week is chapter 1, and part of next week will be chapter 1 too. And actually next week will be chapter 2. Yeah, upward. Then the assignment, you have 3 assignments that I do this week. One of them is the classwork. I will do an example, and then I will show you the one that you need to do. The other one is to assess and get comfortable with the course material. That means to go to this course material to get the code and then go here and register. The third assignment is to download and print the course syllabus. So having said all this, I'm now ready to begin. Statistics. What is statistics? Oh, as a matter of fact, let me take the attendance before I begin. It's very important. Get their names here. Simpkins.
Yeah.
That's Mason. Okay. And I got Harris. Dumas. Is Dumas here?
Yeah.
What's your last name, Dumas? That's Eddie.
Yeah.
Yeah, I see it now. Then I got Eric. Eric, what's your last name? Washington, okay. Jenkins, have Jenkins already. I got Kennedy. Kennedy, can you hear me?
Yes, I can hear you.
Kennedy, Kennedy. Riggins, write it down. Yeah, your name wasn't here before. Riggins.
It's probably because I just switched my class from a
Okay, you
different.
just registered, okay. Daily, Kimura, Daily. Yeah, I'm seeing some names that are new here. Kimura. Kimura, can you hear me? Kimura?
Yes, I can hear you.
Daily, Kimura. Kimura. Daily. Okay, got more. Graham. Marcus.
Yes, I can hear you.
I'm seeing it. Yeah, okay, I've seen it. Morgan. It's Morgan. Morgan, is here?
Yes.
Morgan. Rodney. Rodney, what's your last name?
I'm here, Jones, Rodney Jones. Yeah.
Yep, got it.
Mhm.
Cross. Got it. What you okay? I think I saw the name here. So I got Zakia. I got yes. All right. Now, okay, now I got these names. Let's start. So statistics. What do we do in statistics? What is statistics? We put it that way. So what we do is in statistics that we collect data, we analyze data, and then we interpret data. We are trying to make sense of data. So when we say data, we mean all the observation, any form of observation, such as measurement, gender, even gas prices in a city. These are all data. Unemployment statistics, school enrollment data. These are all information or data that we have. When we say data, we mean any form of observations. Now, yeah. So in statistics, we collect data, we analyze data, we interpret that data. So we use statistics to analyze or to evaluate all kind of published materials, all kind of facts. For example, manufacturers make claims sometimes about their products. For example, those are companies that make pharmaceutical and make claims about their medications. How do they get to the point of making that claim? Because they have collected a lot of the data on that medication, analyze it, and then they can make claim that, oh, okay, this drug, Lipitor, can help in control cholesterol or can lower cholesterol, you know. So statistics help us to make sense of data. Now, how about census data? We collect census. We do census only when we want to study the entire population. That's when we do census. Otherwise, most of the time we use a sample we study the sample and use it to make conclusion about the entire population. So statistics help us to understand and evaluate the result of scientific research. Some of this research are published in newspapers and magazines, and even in journals too. Now, also, how about quality control? Yes, we also use statistics for that. You know, if you have a business or a company, you have to make sure that your products have good quality so that you don't make your customers to be angry with you and, you know, take the business to somebody else, or even sue you. Sometimes they sue company. So it's about data. Collect data, analyze data, interpret data. That's what we do in statistics. Now, the basic concepts we will start from here. Data, which I have already explained a few minutes ago. Then population, sample, parameter, and statistic. Now let's start with this data again. Again, like I explained a few minutes ago, all kinds of observations, counts, measurements, and responses are what we call data. For example, look at the example I have here on the screen. Say people who eat 3 daily servings of whole grains have been shown to reduce their risk of stroke by 37%. Well, that's another one. Is a data. How about this? Stock prices in the stock market. They're all data. How about test scores of high school students? These are all data. Number of patients that were infected by COVID-19 virus. That one is also data. Gas prices in Baltimore City, they're all data. Unemployment, as a matter of fact, every first Friday of the month, the US Department of Labor publishes the unemployment statistics showing how many people are employed, how many are not, how many are looking for a job. These are also data. Now, population and sample. Usually when you say population, people will start thinking about human beings. But population is not only about human beings in statistics. Population actually consists of all outcomes, responses, measurements, or count that are of interest. Excuse me. So, in other words, number of gas stations in Baltimore City is a population. Number of laptops manufactured in the whole US in 2023 is also a population. So population can be human beings, or it can be living things or non-living things. Okay, so number of liquors, alcohol. Let me say, number of Hennessy sold in US in 2023 is also a population. So all outcomes, responses, measurement, count of interest is population. Even the number of fish in Chesapeake Bay is also a population. Now, the problem that with the population is that we can't study the entire population all the time. It is time consuming, it is expensive, and the chance of making an error is there. That's why, as a matter of fact, that's one of the reasons why they do census in the US every 10 years, because it takes time, consumes a lot of resources. So what we normally do is that we collect a small part of the population, study that small part, and then use the result to make general conclusion about the entire population. So that small part we collected is called a sample. So a sample is simply the subset of a population. It is a subset of a population. Okay. I think I opened so many files here. So let me close some of them. Yeah, I'm going to close this one so we can have enough room. Okay. Now, let me go back to where we are. So a small part of the population is called a sample. So it's a subset of the population. So sample, I'm going to maximize this. Okay. Now look at examples here. Let's say that the population is all the gas stations in Baltimore City. Let's say that that is our interest. I'm sure that by now you'll be asking yourself, what is this course about? Yeah, it is still statistics. We're still gonna do maths on it, but this week is just the introduction. So to give you the background information about the course. So having said that, we can go back and then say population is all the gas station in the Baltimore City. So the sample will be a small part of Baltimore City. Peak Town is a part of Baltimore City. So if we select a sample from Peak Town, the gas station from Peak Town, then Peak Town gas station become our sample. Another example, if our interest in studying the income of nurses at the Mercy Hospital, we cannot study all the nurses. There are many of them, but you can say, okay, let us just choose the nurses at the intensive care unit of the hospital. So the population means all nurses at the Mercy Hospital, and the sample become the nurses in the intensive care units of the hospital. Yeah. Now, we can now move on to the next routine. I give an example here. In a recent survey, 1,500 adults in the United States were asked if they thought there was solid evidence for global warming. 855 of these adults said yes. Identify the population and the sample and describe the data set. It said identify the population and the sample and then describe the data set or the set. So let's see. We look at this. Said 1,500 adults were asked. So the population can be all the adults in US. I can have it here for you. The population is all the response from all the adults in US. And the sample is the 1,500 adults who were interviewed in the survey. Now, the data set, remember the question says that 855 of the adults said yes, and the rest said no. So that is the data set. So the data set consists of 855 of the adults who said yes, and then 645 that had said no. You can see the population is the whole universe. Then you can see the sample, a small part of it. So which brings us to the next concept, which is parameter and statistic. Before I go into that, does anybody have a question? If you have a question, you can ask me here. I'm here. I don't respond to chat when I'm teaching. So if you have a question, I'm here. Ask me here now. Any question for me? Yeah. Excellent. Now let's continue. Parameter. Parameter is simply mean a numerical description of the population characteristics. A simple way of saying it that it is a number that describes the population characteristics. So example is the average age of people in US. See the average age of people in US. That's a parameter because it describes the population. It describes the age of the population. But when the number describes the sample characteristics, we call it a statistic. Notice that this is a statistics with no X. There's no S at the end. Call it statistic. So example, the average age of people from a sample of 3 states. So while the parameter is the average age of people in the whole of the United States, the statistic can be average age of people in Virginia, Maryland, and New Jersey. See? So the statistics is that number that describes the sample, while the parameter is that number that describes the population. Okay. Now we have which leads us to next thing in line, which is more example of this. Look at this question. It says, decide whether the numerical value describes a population parameter or a sample statistic. So a recent survey of a sample of college career centers reported that the average starting salary for petroleum engineering majors is $83,121. We're asking you to decide whether this value is describe the population parameter or a statistic. Well, in that college, we have several majors. That called not only petroleum engineering, but this one they picked only petroleum engineering. That means they picked one part of the college majors. So that means this number described is a statistic. It describes a sample statistic because it describes a part of the population of majors that college. You look at this one, it says, decide whether the numerical value describes a population parameter or a sample statistic. It says, the 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1442. See, average SAT score. They say. So, but this number describes all the students who accepted admission that year, all of them. So it is a parameter. It is describing a population parameter. Okay. Now, at this point, we are ready to look at the two branches of statistics. One of them is descriptive statistics, and the other one is the inferential statistics. Now, the descriptive statistics involve, what they do is they organize data, summarize data, and display data. They use charts, things like tables, bar charts, pie charts. Just when they organize them and summarize the data and display it, they stop. They have done their job. So now, inferential statistics now use those data to make conclusion about the population. So why descriptive statistics get the data, present it using tables and charts, and then do nothing anymore. Inferential statistics will now give study the data and then make conclusion and decision based on that. Let's see how it works. Look at this example. It says, decide which part of the study represents the descriptive branch of statistics. What conclusions might be drawn from the study using the inferential statistics? It says, this is the scenario here. It says, in this scenario, that a large sample of men aged 48 were studied for 18 years. For unmarried men, approximately 70% were alive at the age of 65. For married men, 90% were alive at age 65. See, this is descriptive. It just gave you the information, describe them. And it gave you this chart. See what they have, still alive. Let me make it bigger. See, still alive at 65. Or married men, 70%, married men, 90%. See, that's what it did. And they stopped there. Now, inferential statistics will now use this to make a conclusion. And what conclusion was made, you can see right here. According to this chart, we look at it. It says that it says still alive at 65. Unmarried men, 70. Married men, 90. So your inferential statistician when I say, okay, since married men live longer, that means in this data set, married men have 99%. That means that being married is associated with longer life for men. Is that true? I don't know. Because I don't know how they collected the data. But that is what this statistics is telling us. Questions on this? Any question? Okay. Excellent. So we can now proceed to the next thing in line, which is the types of data we have. To have two major types of data. I'm gonna so you can also call it the variables. That's a variable we have, because they still data. I'm gonna use this to illustrate it. The type of data. So I'm gonna use this chart to make it more visible. Types of data. Data sets. So you have data. Okay. I'll use the data or variable or variable. Okay, let me make it bold and a little bigger. Okay. Now we have the next one I'm gonna put, we have quantitative data. Then we have qualitative data. Okay, quantitative data, or I can call it quantitative variable. Then we call this one the qualitative. Let me make it a little bit bigger so that I can. Okay, so I can make it something like 14. Bold. Then we got qualitative data. Or what we call categorical quantitative variable. Qualitative data or categorical data. Categorical data, which can also called categorical qualitative variable. So we can make this bold and then 14. Now with this, we can now see the division of data sets. So I can put the line of, so that it is this. As a matter of fact, let me use a better line. Gonna be quantitative data. Then we have qualitative data. Now this quantitative data is further divided into what we call discrete and continuous. Discrete, okay. Discrete data, and then we have continuous data. Discrete data, then we have continuous data. I'm gonna make it bold. And we can make it 14. Make this 14. So I can use this so that this is the division from here and here. So this is it. Variable, qualitative data, quantitative data, qualitative. Now, quantitative is also divided into discrete and continuous. So let's show you the picture of how we can divide data. Now, having shown you the picture, we can now go back to our presentation. So let's start with qualitative data. As the name implies, qualitative data refers to attributes, labels, names, non-numerical entries. So you have to do with name or quality. For example, major. Yeah, major can be accounting, finance, nursing, engineering. These are not numbers. These are qualitative data. Place of birth, eye color. These are all qualitative. Okay. So remember, in statistics, we are trying to make sense of data. So that data can be qualitative or quantitative. Now look at the quantitative can be, which has numbers. There are numerical counts or measurements. Things like age, weight, temperature. Now, like I said on this chart that I just drew, we can classify quantitative data into discrete and continuous. Okay. Now, the discrete data, why do we call them discrete data? We call them discrete data because they can be counted. They can be counted. See? Discrete can be counted. Let me go to that here. Discrete variable or discrete data. You can count them. For example, number of calls that you receive in your cell phone today. Maybe 1 call, 2 calls, 3 calls to your cell phone. You know, can be that. Now, you cannot say that you receive 1.5 calls. You see? You can't say that. Now, how about number of students in a classroom? 1 student, like now I have 16 students in my classroom. So I can't say 16.5. You see? I can count them. So we can we call them discrete data or discrete variable. Continuous data, you cannot count. Instead, you can measure them. You measure them. Things like height, weight, temperature. Okay? Call it continuous variable. Now, let's say we can also classify data into 4 major groups. Again, this is another way of classifying data. We call them levels of measurement or types of data. Now, the first level is called the nominal level of measurement. Nominal level of measurement, we have they are qualitative. As the name, that means they're not numbers, they're names. Even if they are numbers, that number represents a name. For example, your social security number represents your name. Your zip code represents the name of your city. So we categorize them using labels and qualities and so on and so forth. Good example are things like your political party that you belong to, your eye color, your city, and so on and so forth. Now, ordinal data or ordinal level of measurement can be numbers or names, but it is different from this one because it can be ranked in order. See, it can be arranged in order. It can be ranked. Nominal data cannot be ranked, but this one can be ranked. Now, let me give a good example is your grade. See, so example of this. Nominal, your political party that you belong to, your marital status, married, single, divorced. These are not numbers. Religion, Christian, Muslim, Hindu. But for the ordinal, it can be numbers or not number, but main thing that they can be ranked. Like if you are interested in the educational level, you can use 1 to represent high school diploma, 2 to represent associate degree, 3 for bachelor's degree, and 4 for master's. And their grades have A, B, C, so they can be ranked. So a good example, you can see one example here. You can look at this question here. It says 2 data sets are shown here. Which data set consists of data in the nominal level? And which of them consists of data in the ordinal? You can see that this one is top 5 TV programs. This one is the network affiliates in Pittsburgh. So this one is a names. So this one is nominal. But this one is top 5 TV programs. That means they are ranked. So they are ordinal data. You can also see from here. Ordinal data, because this lists the ranks of 5 TV programs. So data can be ordered. This one is nominal because it lists the cause letters for each network affiliate. So now look, at this point, we're ready to look at the interval level of measurement or interval data. This one, it can also be ordered. However, the difference between the data entries are meaningful. Well, it can be meaningful, yes, okay, but it doesn't have an absolute zero. A good example of this is temperature. Temperature have 0 degrees, but it doesn't stop at 0. It goes beyond that, above, all the way to 100, 105, or below to -10, -20, even all the way to -100. It doesn't stop, keep going on both ways. So 0 degrees does not mean that there's no temperature. There's a temperature, but it's just that it's 0 degrees. So ordinary data doesn't have an absolute zero. It doesn't have a true zero. So now another example of ordinary data. I'm sorry, for this is interval data. I mean to say, not ordinary, interval data. Okay. Another example of interval data is IQ. So the IQ, of course, is called the intelligence quotient. There is no meaningful difference between one point. If somebody has a 0 IQ, that does not mean that the person doesn't know anything. He does know anything. At least he knows how to eat. So you have no absolute zero. How about time? Time of the day. Time starts from 1 a.m., 12 noon, 12 midnight, 1 a.m. So it doesn't stop. You have no absolute zero. Another one is year. Year continues. And we have the time, the Ice Age. There's even time before the Ice Age. Then all the way down to the Middle Ages. Now, it doesn't stop. You have no absolute zero. So yeah, it's another good example of interval data. So now, next is the ratio. This is the one you are familiar with. Ratio. Now, before I explain what ratio data means, look at the other data set, that type of data we have. We have the nominal. Nominal data, you cannot add them. You cannot say, let's say that we are talking about political party. You cannot say Republican plus Democrat. You won't get an answer. So you can't add them, you cannot multiply them. The same thing with qualitative data. I mean, with the ordinary data. If it is grade A plus grade B, let's say that your grade that gave you A is 85%, and the one that gave you B is, sorry, the one that gave you A is 95%, and the one that gave you B is 80%. 95 plus 80, of course, you're gonna get an answer, but that answer doesn't have any meaning. So you cannot really do any mathematical operation with them. I mean, some of them you can do, but I mean, you can't do, it doesn't make sense to do mathematical operation with them. The same thing with the interval data. Yeah, let's say age. I mean, let's say the year, 1985 plus 1999. Of course, you're going to get an answer, but the answer doesn't have any meaning. I mean, for interval data, you can do some mathematical math with it, but not all of them. Not all of them. Okay. Then, but for ratio data, you can do everything with it. You can add them, multiply them, divide them, subtract them. Not only that, ratio data has true zero. It has absolute zero. So, good example, we have weight, height, area, number of phone calls received. If you have 0 calls, that means you didn't receive any call. So it has absolute zero. If you have a business and you didn't get the client today, that means you have no client. It's simple as that, Excuse me. Now, so that's why where ratio data is different from interval. Whereas interval has no absolute zero. Ratio have absolute zero. You can see all this in this summary of this table. See? Nominal, you can put them in categories, but can you put them in order? Nope. Can you subtract the values? Nope. and so on and so forth. Ordinary, you can do certain, but not all of them. You can arrange them in order. You can
Laptop.
So now, next will be interval. You can put them in order. You can arrange. You can subtract data values. Because let's say that temperature yesterday was 85 degrees Fahrenheit, and today is 90 degrees Fahrenheit. You can say, okay, what is the difference in temperature? You know, you can do that. But to add the two of them, you can't. If you add them, you get an answer, but it doesn't make any sense. But for ratio data, you can do all of them. Yes, 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 yes. Any question before I continue? Any question, guys? Okay, excellent. So yeah, you guys are good. Now, which lead us to the concept of designing a statistical study. What we do, 6 steps: identify the variable of interest and the population of, what they call the target population. Then develop a detailed plan for collecting the data. And if you're using a sample, you can make sure the sample is representative of the population. And you collect the data, describe the data using descriptive statistics, analyze it and interpret it, and make decision. So let's start the steps you go when we conduct a statistical study, which you're gonna do when you start doing your project at the end of the semester. So let's start with data collection. How do we collect data? Now remember that in statistics, everything we do is driven by the type of data we collect. Now there are 2 ways you can collect that. 2 ways: observational studies and experiments. Now, in observational study, the researcher observes and measures the characteristics of the part of the population. For example, I'm sure you guys know about the Pew Research Center. They conduct surveys regularly. So they surveyed 2,252 adults and found that 59% of them go online wirelessly. So this is a kind of observational study because the adults did not receive any treatment. You just, probably ask them questions, but no treatment was given to them. When I say treatment, was nothing was applied. No food was given to them. There wasn't anything physical that was given to them during the test. If there's a test for them, just a survey, call them, or probably send them questionnaire to fill. Now, but in experiments, a treatment is applied. The treatment doesn't have to be medication. It can be anything. It can be anything that we are testing. For example, an experiment was performed in which diabetics took cinnamon extract, okay, while a control group took none. So after 40 days, the diabetics who have cinnamon, who took the cinnamon, reduce their risk of heart disease, while the control group experienced no change. So in this case, what was given to them was cinnamon. Cinnamon become the treatment that is applied. So let me, because usually in a statistical study, we normally have, in an experimental study, let's say the experiment, how it is done. The experiments, I think I'm gonna go to the next page so that we can have enough room for this. Okay, experiment. Okay, let me use a chart to illustrate it. Experimental study. Okay, study. So we have the 2 groups. They have what we call the experimental group. Okay, experimental group. Okay, and we have the control group. Control group. Now, the experimental group are the one that will receive the treatment, which in this case is cinnamon extract. Okay. The control group will receive nothing. So that if there's any change in the experimental group, we can attribute that change to the cinnamon extract. So, like I said, usually they are divided into the experimental group and then the control group. See? So this received the cinnamon extract. Cinnamon extract was given to this group. Given. This one, no cinnamon extract. Okay. No cinnamon extract. See? And then they will observe them for a number of days. So if there's any change in this experimental group, that it might be because of the cinnamon extract. In this case, the cinnamon, the cinnamon extract becomes the treatment. Okay, let me make it bold. Now, in some cases, they might give let's say that this is for medication. They might give the medication to this group, but this group, they give them something that looks like the medication. They call it the placebo. Let me see. All right, let's see how it goes. Yep. You might give them something that look like they might even give them something that look like a cinnamon extract, but not cinnamon extract. They call it placebo. That looks like the medicine or the cinnamon extract, but it is not. They can give it to this group, the other group. So they will be thinking that they are taking the cinnamon extract, but they are not taking anything. So that they can now observe and see what happens. If anything that changes, that means it will become attributed to the cinnamon extract. If it's medication, let's say that this is a medication for cholesterol, you might give this group Lipitor, and then give this group something that looks like Lipitor. It might be just ordinary, it may be sugar pills, and they will be thinking that they are taking Lipitor. But actually, they're taking the placebo. So that they can now figure out what effect this will have on each group. Now, going back, to have I mentioned them. Other ways of collecting data, we can use simulation and surveys to collect data as well. Simulation. Now we use simulation when it is not really practical to do the experiment, to do the actual experiments. So we use simulation to reproduce the condition of a situation in a process. For example, automobile manufacturers use simulation a lot. Let's say that they are trying to make claims about how safe their car can be during a crash, maybe an accident. They're not going to put some human beings behind the car and say, go and crash the car, because that is not practical. The person might die. So what they do is they simulate it. They might put a dummy in the car and then use it, or they can just simulate it. That will make it to because it's not realistic to just put human beings in the car and say, go and crash it to prove that our car is safe. Anything can happen. So we use this simulation when it's not practical to do the actual experiments. Now, the next one is survey. Survey is an investigation of one or more characteristics of the population. And we can get this survey and conduct it using interview, mail, or telephone. For example, we have a survey that is conducted on a sample of female physicians to determine whether their primary reason for their career choice is financial stability. Yeah, the investigator might ask them these questions. I mean, or question that can be interpreted this way. Let's look at a few examples. People, they say, consider the following statistical studies. It says, which method of data collection will you use for each of these studies? Let's look at the first one. It says, a study of the effect of changing flight patterns on the number of airplane accidents. Changing flight pattern on the number of airplane accidents. What's the effect? Now, this kind of you want to change, study or evaluate the effect of changing flight patterns on the number of airplane accidents. You're not going to put pilots of different planes to go in the air and start driving different, erratically. That would be very disastrous. So they might crash. So for this kind of study, use simulation because it is impractical to create this situation. We can do it within computer. How about this type, where we have a study of the effect of eating oatmeal on lowering blood pressure? Yeah, the manufacturer there's one that I think it's oatmeal. They have a picture of a heart. Say that it's good for the heart. Who knows? So to do that, people have to eat oatmeal. You have to select two groups, like I mentioned here in my other chart. You might select two groups. This group ate given oatmeal. Okay. For let's say maybe 40 people. Let's say for 6 months. This group will not. No oatmeal. In that case, oatmeal become the treatment in the control group. And you can observe them, check their blood pressure after that 6 months. If there's any change, you can attribute it to because of the oatmeal that the experimental group were giving. So this is an experiment. Experiment can be still for this kind of study. Now, how about this one? A study of how 4th grade students solve a puzzle. In this case, observational study will be better because you can observe them directly. Yeah. Now, in this one, we have a study of the U.S. resident approval rating of the U.S. president. This one, a survey will do this one. Matter of fact, they do it election during the polls, political polls. They do it, they ask questions and then publish it. Yep. So at this point, we're going to look at the key element of experimental design. Before I do that, does anybody have questions? If you have questions, ask me here. I don't respond to chats room while I'm teaching. So if you have any question, ask me here. I'm right here now. Any question for me before I continue? Yeah. So now the key element of experimental design, we have control, randomization, and replication. So all these key elements, these three things, control, randomization, and replication, they help scientists to conduct a fair and reliable experiments, which lead to trustworthy conclusions. Let's start with control. I've already given you an example of the control where you will have the two groups. You have the experimental group that will receive the extract, cinnamon extract, or just oatmeal, okay? Or just oatmeal. This one receive no oatmeal. So so that means this one doesn't receive oatmeal. That means you are controlled for oatmeal. That means they don't have any oatmeal. So have oatmeal. So you have control. So the control is the same type of control we're talking about here. That means you keep all the variables the same except for the one that is being tested, which in this case is oatmeal or cinnamon extract. So by doing that, you can see the effect of the tested variable without interference on the other variables. We use it in many ways. For example, look at this testing that involve new plant fertilizer. So in that case, you have two group of plants. One group, that's the experimental group, we get the fertilizer. The other group, control group, can get no fertilizer, or can just get the regular fertilizer. This one get the new fertilizer, the experimental group. Now, both groups are now treated the same with the same amount of water, light, and soil. Then you can observe the change. Now, if there's any change in the experimental group, it might be due to the new fertilizer. Now, next thing is the randomization. Now, under randomization, what do? Where we assign subjects to different groups in a way that each subject have equal chance of being put in any group. So with this, we can be sure that the group that are similar and also that the result of the experiment are not biased. So every member of the group have equal chance. So no biasness. For example, in a clinical trial, patients are randomly selected to receive either the new drug or the placebo. So that means because the patients are selected at random, each patient has equal chance of being selected to get the drug or the placebo. And this helps them to ensure that there is no biasness in the result of the experiment. Which leads us to replication. Now, replication means testing. Let's say that somebody did an experiment like this COVID-19 vaccine, for example. Different companies, Pfizer did an experiment on it, the vaccine, with the new vaccine, the new virus, and developed their own vaccine. Another group, I think Moderna, did their own, replicate almost the same thing that Pfizer did, and they get their own vaccine. So replication means, so that thing that you did, somebody can do it and get the same result. So we use it a lot in science to confirm the findings that from different experiments to make sure that what I found wasn't as a result due to a chance, but it is consistent. Called replication. For example, after conducting the initial experiment with new fertilizer, you can repeat the same experiment with different batches of plants several times. Now, if the results are similar each time, then you can be more confident that your conclusion is not as a result of chance. So replication can also involve retesting other things. So it is very common in science. What he did, somebody else will do it, and that is how most of the scientific theories we are, developed. Right. Now we can now control group and control group and experimental group. I have already explained it. So using the chart. Now let's look at what they call confounding variables. Now, this occurs when an experimenter cannot tell the difference between the effects of different factors in the variable. Let's look at an example here. A coffee shop owner remodels her shop the same time that a nearby mall has its grand opening. So business was good. Business picked up. But the coffee shop owner doesn't know whether the increase in business he's getting is from the remodeling that he did or because of the new mall. So there's a confounding variable there. How about this one? It says exercise and weight loss. In a study examining the effect of exercise on weight loss, diet could be a confounding variable. Yes, because people who exercise may also follow eat healthy diets. So, and this contributes to their weight loss. So if that happens, in that case, diet isn't controlled for, and it becomes the confounding variable. And because of that, we don't know exactly whether where the effect of exercise starts and stops, and where diet picks up. We don't know whether the weight loss is because of the exercise or because of the diet. Because people that do try to lose weight, they also eat diet. They also eat. They watch what they eat. Let me put it that way. So diet in this case is the confounding variable. And there are many examples, and I encourage you to look up more examples of that. Next would be placebo effect. So in this case, a subject reacts favorably to a placebo when in fact he or she has been given no medical treatments at all. I gave you an example with the one on the chart. So let's say that this is Lipitor for cholesterol, Lipitor. Okay, this is a new drug, Lipitor 2, for example. Let's say that this one was developed by another pharmaceutical company. And this one, there's no Lipitor for the control group. So in the experimental group, they were given Lipitor. And the control group was given a placebo. See? Placebo. Okay, let me put it that way. Placebo was given. Placebo was given. Placebo. Now they can watch them for 6 months. If this group have their cholesterol level, lowered, of course, people in this group are also taking the placebo, but not the Lipitor. So they think that actually they're taking the real medicine, but they're not. But psychologically, it might have, let's say 90% of this group, 90% of them, 90% have their cholesterol level declined. Okay, 90%. It might be that this group, because of the fact that they believe that they're taking the medication, it might be only 10% that have their own lower. Psychologically, it can trigger some process in their body that lower the cholesterol. So now we cannot conclude that actually this Lipitor was the pharmaceutical agent that actually led to the significant decline in cholesterol level. And when we can conclude that it's a good medication for managing cholesterol. So that's what we are trying to I want to explain here, that what I mentioned about this other group that doesn't receive the Lipitor, but yet they have 10% of them have their cholesterol reduced, is what we call placebo effect. They think that they are getting medicine. They start acting a certain way, and their body start acting in a certain way that actually led to the reduction of the cholesterol level. I mean, this is not big. It doesn't happen often. So we call it placebo effect. It happens because they think they are taking the real medicine, which they are not. Okay. Now, so I have made there are different examples. Let's look at the better sleep with placebo sleep aids. You see here, insomniacs are given placebo periods that they are told are powerful sleep aids. Several participants report falling asleep faster and having a better quality of sleep, despite the fact that the pill contains no active sleep-inducing agents. So they were just, psychologically allow themselves to fall asleep, and they say, okay, it might be because of the medication I took, but they don't know that what they took was a placebo, not the real medication. Excuse me. Now, this is the blinding. Now, the one I just discussed, I said that those that took the placebo don't know. That means they are blinded, kind of. So blinding is a method that we use in science, whereby the subject does not know whether he or she is receiving the treatment or not, or a placebo. So sometimes we might have double blind, whereby the person giving them the medication don't know which one is the placebo or which one is the real medication. So then the people who are taking the medication don't even know either. So they have double blind. But the person that owned the experiment knows. So, but the individual that administered the medication doesn't know. The participant doesn't know. So you call it double blind. So always the reason is always to make sure that the results can be is not by it doesn't occur by chance. Okay. Now, so now we have another three more concepts to be looking at. One is randomization, and the other one is completely randomized design, and then another one is the randomized block design. Randomization simply means the process of randomly assigning subjects to different treatment groups, at random. So in a completely randomized design, the subjects are assigned to different groups through a random selection. Everything is completely randomized. That means every observation or every subject have equal chance of being selected. But in a randomized block design, like this one, we divide the subject into groups that we call blocks. And then within each block, we can, randomly assign subjects. So let's take a quick look at this. Look at this experiment. Say an experimenter testing the effect of new weight loss drink may divide the subject into 8 categories. Then within those 8 categories, then they can randomly select subjects to assign to either the treatment group or the control group. So now look at this. All the subjects, they are divided into 3 groups based on age. This one is age 30 to 39, 40 to 49, and then 50 to 52 years over 50. Now, for this group, these 3 groups are what they call the blocks. The blocks. Note that a block simply means a group of subjects that are similar. Yeah, but now that means there might be groups of that have the same or similar demographic experience. So within each block, you can divide this block of 30 to 39-year-old individuals into 2, the control and the treatment. The same thing happens here, the control and treatment, over 50, control and treatment. Okay? Now, there's another one we call matched pair, whereby one subject in the pair is selected at random to receive one treatment, while the other subject receive a different treatment. So usually, we use this when testing a new pen medication. For example, in this case, researchers want to know medication. I mean, they can recruit patients who have chronic back pain, and they develop this medication for chronic back pain. So they can now select each of the patients and match them with another individual of similar age, similar medical history, and pain intensity. So one group will now receive the new medication, while the other one receive the placebo, and then we can compare the result after. Of course, the result have to be with change in pain levels within each pair, of the people that receive the medication. Okay, which leads to replication. Any question about what I have covered so far? Any question? Hello, guys, are you still there? Hello?
Yes, we're here.
Any question for me?
No.
Okay,
Not
good.
at this moment.
No
Okay.
questions.
Okay, good. Excellent. Now, replication, I think I mentioned it already. Repeat the experiment using a larger group to make sure that the result you got in the first attempt wasn't as a result of chance. Okay? For example, to test the vaccine against a strain of influenza, you can select 10 people and give them the vaccine. Then select another 10 people and give them the placebo. Now, then the result we have, you can repeat it again after you have completed this one and then write the report. You can repeat it with different group of people, and then write the report. Then compare results. Make sure that it wasn't as a result of chance. Look at this question here. It says a company want to test the effectiveness of a new gum developed to help people quit smoking. If identify the potential problem with the given experimental design and suggest a way to improve it. So look at the design here. It says the company identified 1,000 adults who are heavy smokers. Then the subjects are divided into blocks according to them, gender. Females are given the new gum, and males are given the placebo. After 2 months, the female group have quit. Has a significant number of them who quit smoking. This experiment is not correct because it was not prepared the right way. The group are not the same. So in this case, the way they should do it is this is the for the a new gum that had a quit medication. You can have this is the population. Okay, have the this can be first group can be men. I'm gonna move got it. I'm gonna have this. Next one can be have this as male. Then this as the female. Okay. Male can receive the among the males, males, females, right? So the male can receive the okay, this male will receive the new gum, then and then of course this is the experimental group. You have the new gum. Okay, the new gum ahead and quit smoking. They receive it. Okay. Then you're gonna have another group that is called a placebo. Did not receive the new gum. They received the placebo. Okay. Placebo. So we have this is new gum, placebo. The same group of men. You have two groups, one that receive the new gum and placebo. The same thing will happen to the female side. They will receive the new gum and the placebo. Okay, the new gum as well. They have new gum here. Okay. This one will see the placebo. Placebo. So this is the two of them. Oh, excuse me, I pinned the wrong thing. The placebo. So now you can see. Now it is now a reduced biasness. So if this group quit smoking, this group that received new gum quit smoking for the males, and this group of more people quit smoking for female, then you can now make an unbiased conclusion that the new gum helped in quitting smoking. Okay. Now, so the solid can be divided into blocks. And what I have here, you can see the blocks here. I see the first block, second block. Then for each block, we have new gum and placebo, new gum and placebo. Okay. So now we have the and they must have, of course, they must have randomly assigned to the different treatment group or the control group. Now, when I started this tonight, the class tonight, I mentioned that in statistics, what we do is to collect data, analyze data, and interpret data. Now, how do we collect data? I have already mentioned a group through surveys and other ways. We can also, let's see, you can also, when you collect data, you collect a sample from the population. Most time, you don't study the entire population. Instead, you study the sample and use the sample to make conclusion about the population. So what are the sampling methods? We're looking at the one we call sampling techniques. I call it the probability sampling techniques, because in this kind of sampling, each member of the population have equal chance to be selected. We have the simple random sampling, stratified sampling, cluster sampling, systematic sampling, and combination sampling. Actually, combination sampling is not probability sampling, so I'm going to remove it. It's not a probability sampling method. Let's start with simple random sampling. Your classwork is based on that. So anyway, in simple random sampling, every possible sample of the same size have equal chance of being selected. So we use random numbers to select it, or we can use a statistical software. In this case, we're going to be using Excel to select it. I'm going to do an example here. Now remember, your classwork is the classwork. What I'm going to do in this example is what you'll be doing in your classwork. My own, I'm going to be using the states. But for your classwork, you'll be using the medication. This is what you're going to use for you. You have to download this. Before you do the class, watch this video first. That will tell you exactly. And I'm going to do exactly the same thing using states. What I'm doing is a good example of the simple random sampling method, whereby all the members of the population have equal chance of being selected. Like I said, you can do it using a statistical a table of random numbers, or you can do it using a calculator. You can do it using a software. So I'm going to do it with Excel. Look at the question I'm going to use to illustrate simple random sampling. Look at my question here. It says, let me make it a little bit bigger. 14 should be good. It says, suppose a researcher, make it a little bit more, 18. It says, suppose a researcher, it's not class, this is for, yeah. Yeah. Now, it says, suppose the researcher want to study the, a TV show featuring in-depth interviews. Want to produce a TV show that featuring in-depth interviews with state governors on the subject of capital punishment. Because of the time constraints, the 60-minute program will have room for only 10 governors. The researcher wishes to select the governors at random. Using Excel, you are required to help the researcher to select a random sample of 10 states from 50 states. So you are required to select 10 states from 50 states. Since I'm going to use Excel, this is the formula we'll be using. Round between function. Now I'm selecting 10 states out of 50 states. So I'm going to start from 1 So I give them, you have to first need to give the number to number your data set. And number from 01 to 50. That's why I have 150. So now let's do it. I'm gonna do it. Now, for you, your classwork will be you're gonna use the medication I provided to do your own and then upload. So let's do it. I have the names already. So I'm gonna go to Excel. Since I have 50 states, I'm my interest in 10 states. So I'm going to go to Excel. You know how to open Excel. Open Excel. Then I'm gonna make it yep, right here. So I'm gonna do equal. Remember that the formula is run between. What is it? Run between. Starting from 1 to 50. If I have 40 numbers, I'm going to use run between 1, 40. If I have 30 numbers to select from, I'm going to do run between 1, 30. Yeah. So now I have 50. So I'm going to use this and put equal round between. It pops out right here. You double click on it. 1, 50. Close the parenthesis. Now so you can now press the enter key. Then click on it. See this small box here. Click on it and you see this is a tick cross. When I bring it closer to this box, it changes to skinny one. When it changes to the skinny one, click, hold, and drag until you get to the 10 that you need. See, if you look at down here, it says 10. I mean, I have 10 of them. Okay. Now I have 10. Now notice that if I want to continue, as I'm moving down, they'll be changing. See, they keep changing. So that's why once you got all the way to 10, you stop. Okay. See, they keep changing. So now let me see. If I highlight all of them, let's see. It's still the same 10, count is 10. Okay, you stop there. Now you can use a pen to write them out. Numbers out. So, or like I said, I can even start doing it again if for those of you who didn't get the first attempt. So let me erase it. So then I have equal run between. If you pop out, double click 1, 50. Okay. Now click on it, then move this cross, this tick cross close. Once you change to a skinny one, click, hold, and drag it until you get 10 of them. So 1, 2, 3, 4, 5, 6. So let me look at it. Go down, you can see that it's 10. Count is 10. Okay. Now, if I click anywhere, it will change. So to avoid that, just use a pen to write numbers out that you have. I got 2, 1, 21, 15, 44, 16, 22, 25, 28, 43. Okay. Now we have it. Then you save this. Save it because you're gonna submit it together with your selection. So I need to see both of them. Now you can go to your assignment paper and type those numbers in. My own, I'm gonna type them in. So now I can have 1, 2. What states have number 2? It's called Alaska. So I'm gonna put Alaska there. So Alaska is selected. I'm gonna have so I'm gonna make it to be 14. Next number I have You look at this chart. Next number I have is 1. 1. So I'm gonna go there and put 1. I put 1 here. 1. What state have number 1? Alabama. So I'll continue like this until I get 10 states. That means I can interview the governors in those states. Next one I have there is, remember, if you click on it, or if you type something here anywhere, it will change. So don't click on it. Next one is 21. I go there and then when I put 21, what state is 21? 21 is Massachusetts. So Massachusetts. Massachusetts. So I continue until I get my 10 numbers. Okay. Next will be look at the shall have 15. 15. So I'm gonna put 15 right there. 15. What state have that number? We got Iowa. Iowa. Then next number we have will be 15 have 44. 44. Okay, we have 44. 44. What state has that? Utah. 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 Okay. Next will be what number do I have in my random selection? I have 16. So I'm going there and put 16. 16. What number? What state have the number 16? Kansas. Kansas. So next number in the list is 22. 22. 22. So now 22 will be Michigan. Michigan. The next number we have will be next will be 25. So I'm gonna write 25 here. 25. And that is for Missouri. Okay, Missouri. Then we have next number, which is 28. 28. Which would be Nevada. Yeah. Then next one will be 43. 43. 43. And that would be Texas. So now when you finish, you upload, save this, and then save that. Upload both of them. When I'm grading it, I'm gonna be clicking on the numbers. When I click on it, I'll look at your work. It will show me what you did. Click on it. See, it shows. So now, don't type somebody's work. If you type something else and didn't do the work, actually do the work, that make it to have the, a 0 grade on the assignment. I need to click. I need to see that when I click on this answer, I will see what you did. Then I can now go to your the work that you uploaded. I mean, the medication that you selected, and then I'll give you a grade. So if you go and copy somebody's work, let me show you an example. Let's say that Let me open a new page. This is that somebody didn't do the work. Somebody went and copied this from another person. 2, 1, 21. Okay, 15. These are numbers we have. Okay, 16, 22, 25, 28, 43. So let's say somebody went and copied. Oh, did I close it? Okay. Let me see. I'm gonna go back to it. I think I close on something. Okay, share it. Okay, good. Now, make sure I've seen this. All right, let me make sure again. Now, if I'm grading this, I'll click on the answer. It doesn't show me any work done here on it. So when you submit this and submit this work, you will not get a credit on that. So I want to make sure you did it and then submit both files. So that's tell us how you can see that in this selection, there was no bias at all. There was no bias. Even it was so unbiased that even I did not even select my own state of Maryland here. Even though I'm from Maryland, I wasn't able to select Maryland because all the states have equal chance. That is the beauty of simple random sampling method. Any question in what I did? Any question? Okay, no question. Good. Now, going back to the presentation, you can have okay. Yep. Okay, good. Let me go back again to it. Good. Now, we just finished the simple random sampling technique. Look at the other sampling methods. Have stratified sampling. In stratified sampling, you divide the target population into groups and select random sample from each group. For example, to collect the stratified sample of number of people who live in West Ridge County household, you can divide the household into groups by their socioeconomic level and then select a sample from each group. So each group is called a stratum. If there are two of them, we call it strata. Now, this one is cluster sample. So cluster sample, we divide the sample into groups. Then you choose, you randomly select one group and study all the elements in that group. For example, now in the same West Ridge County example that we divide the household into clusters according to their zip code. So you can see the zip code here, zip code 1, zip code 2, 3, and 4. Now you choose this one zip code at random and studied all the members of the sample within that zip code. Yeah, that's why it's different from the stratify. Stratify that you select from each group and select sample from each group. You don't select everything in that group, just sample. But in the cluster, you select a group at random, then study all the elements in that group. Yeah. Then next is systematic sample. Where in this case, you choose a starting point at random. Then you choose every care member of the population, care member. Now, let's say that our interest is to study the income of households in West Ridge County. You must start at a random, maybe address. Let's say that this address you started was 5 Banker Place. Then you can say, okay, I'm going to study every 10th house. So that means next house is going to be 15 Banker Place. The next one going to be 25 Banker Place, just like that. They call it systematic sampling method. And of course, now this brings us to the convenience sampling. Convenience sampling is a type of probability sampling method where the researcher select a sample at their own convenience, samples that are easy to get. So, for example, a college student who is doing a term paper might want to know the average consumption of soda in the college town on Friday night. So to do that, the student might just call some of his friends or her friends and ask them how many cans of soda they drink. So this is a convenience sampling. And many of the political polls I see on TV, I think they are convenience sampling. That's why sometimes they keep changing, or they might say that this person is winning, then another person wins. So they're convenience sampling. Yeah. Now, let's see. Any question before we leave for today? Any question? Any question? Yeah. So now let me take you back to the classroom, and then we can look at I can show you where the classwork is, and you can then start doing it. It's due to tonight, but like I said, you can also submit it tomorrow. I'll accept it. So I'm gonna take you there now to the my home page. What is the Morgan State? Okay, good. So let me take you there. Yeah, as a page right here. Now, if you go to the models, you see the classwork right here, random sample exercise. Now you're gonna download this. This is your own version. My own was the state. Your own is medications. You read it, and you're gonna use even though I wrote table of random numbers, you can use the Excel, do your own selection, then write your answers here, number and the answer. Then, of course, you're gonna upload this and your Excel file, so I can see how you made a selection. Okay, and that is it for today. So I will leave you to go and complete this classwork and submit. When you finish, you can upload it here for grading. And if there's no other question, then you're free to. How?
Just to make sure you said write all your answers on the Excel sheet, correct?
You do the work on the Excel sheet you generate the numbers from the Excel sheet, then write your answer here.
Okay.
Yeah. So then you submit both files. So if I'm going to submit this one that have your answer and the Excel sheet, so I can click on them and see if you actually did the work and how you did it.
Okay.
Yeah. And then, like I say, if you don't have any other question, I will say good night, and I'll see you guys next week.
Thank you, Doctor.
Sure, you're welcome. Yes, I think I saw this person. Yes, that's so.
Question, will we get more time for chapter 1 homework and classwork? Not classwork.
Classwork is due tonight. The homework, I haven't put the homework yet. Because I want to fix this huh?
The math, the MyLab and mastering.
Yeah, I have to fix that problem first.
Yeah, so will we get more time when they open up? If it opens up
when they fix it, then I can then put the homework. Homework would be, let's say, like if I put the homework on Monday, then they will be due on Sunday. That's the weekend. So you have like 7 days to do it. That should be enough.
Right. Okay.
So now, just to worry about the classwork, that's the main thing that you can do now to get your credit.
Okay.
All right, guys. Any other question? Those of you who are still here, do you have a question for me? Yeah. All right.
No.
Okay, good. So you guys have a good night then. Oh, I'm going to post this video. I mean, if you want it, but I think we are good though. Yeah. All right, I'll see you guys next week.
See you.